of this subject, but I would give you a brief lecture on generally on the implants and biomaterials, but that would be next week. Okay. Basically, the plan, as I was telling you, is to hold the major test 2 on 12th of April. So by next week, I would like to, not next week, the week after, we would like to end the class so that you have sufficient time. By around, say, 7th, 8th, I would like to end all aspects of the class, including doubt clearing. I would be always available, but generally I would like to end the class during 7th, 8th of, by 7th, 8th of April. Okay, is that okay for all of you? Hello?
Yes, sir.
Yes, sir.
So, and 12th of April, we have the major test 1. Now, what about the home assignment? Have you all submitted?
Yes,
Assignment. People who are in the class?
Yes, sir.
Okay. That's good. So you got sufficient time. Just waiting for this to open. Just a moment. Now I will start the lecture on bone fracture healing mechanobiology with a PPT as well as a supporting PDF document. Okay. So bone ingrowth, tissue differentiation, both of them are available in your Google Drive. Okay. But I will just show you in the lecture so that, and discuss as well, so that you do not have any problems following the topic. So to start with, I will go to slide share mode. Yeah, by the way, did you had time to go through my earlier lecture? Hello?
Sir, which one?
So the last lecture that I presented on Friday.
Sir, we attended in the class itself. There was no recording, so I mean you're asking about the GAN, sir?
No. The last lecture I discussed on Friday on the shoulder replacement failures. Hello? The shoulder glenoid replacement, interface failure. Did you get my point? Hello?
Yes, sir. So you're talking about the GAN lecture that you recommended, sir, for this one?
No, GAN lecture is basically available, but this, regarding the shoulder replacement.
Yes, sir, that we have gone through.
And I had discussed in the class itself, isn't it? On last Friday, I discussed in the class
Yes, sir.
regarding this shoulder replacement, and that basically the same thing is applicable for all other joints. So that was the whole procedure, the mathematical procedure or the sort of that we discussed regarding interface failure, Hoffman's failure criteria. Is it clear to all of you?
Yes, sir.
That I wanted to know. That biaxial failure criteria with strength, local values of normal and shear stresses, those things. And how failure, if it is applicable, when it is applicable to shoulder joint, shoulder replacement, how this whole thing is, the chances of failure can be evaluated, based on different locations. So how the local strength as well as the stresses generated at the interface, the normal and shear stresses, combined with the local strength, how we are evaluating failure using the Hoffman's failure criteria. That I wanted to ask you. Is it clear to everybody? Okay, then, so let me move to the new topic. Oops. Hello.
Yes, sir.
Yeah. Can you see the slide?
Yes, sir, we can see.
Yes, sir.
So I'll start recording because this doesn't have any recording in the GAN, because this is extension of GAN. So I will start recording. So So today's lecture would be on bone fracture healing. So I will start with biological events and then move into mechanobiology. Okay. So together with my former PhD research fellow, he's now Dr. Kaushik Mukherjee. He's at IIT Delhi now. So we had prepared this set of slides for clear understanding of the biological phenomenon as well as the mechanics involved in the process of bone fracture healing. Now, the reasons of bone fracture can be traumatic as well as pathological. Okay. Now, for different kinds of fall and accidental injuries, we can actually fracture our bone, and that may be categorized within the traumatic events. Pathological reasons may be due to osteoporosis. So, you know what is osteoporosis. Osteo means bone, porosis is connected with porosity, and osteoporosis is a degenerative disease. With age, the porosity of the bone increases and bone degenerates, and the inner core of cancellous bone has very high porosity, and in old age perhaps you have seen or observed in patients that they cannot even support their own body weight, and they break their bones. A little slip and fall can also cause femur neck fracture at old age. The other reason is metastatic cancer, so which leads to reduction in bone quality and ultimately leading to pathological fractures. Now, there are different kinds of bone fracture, which may be classified as follows. It can be, you can see, depending on the direction of the fracture, can be categorized as transverse, linear, more axial, oblique, non-displaced, oblique, and the two fragmented parts are displaced, so they are basically dislocated, in a sense. Spiral fracture can also occur if there is a twisting moment. In case of a twisting moment, there is also other kinds of complex fracture like green stick and communicated, as shown in the figure. So what is the biology behind the bone fracture healing? So as you know, there may be fracture within bone, but that fracture can be healed as well. Okay. Now, how this, what are the events and how this fracture healing goes on within the bone? What are the events exclusively that is occurring during the process of bone fracture healing? That would be discussed now. Now, the sequence of events in bone fracture healing starts with the following. First, what occurs when you fracture a bone is there is inflammation at the fracture site. Then there is soft callus formation. Then that soft callus actually transforms into hard callus. And thereafter, finally, there is remodeling of bone. So bone structure, there around the site, the hard callus actually transforms and forms different kinds of bone. So if I look into this picture as I am viewing it, so it is basically a fractured site immediately after fracture, and you can see that I will just go to the pointer option. You can see the inflammation here. Okay, so this is what is indicated by inflammation. You can see the bone has been fractured into two parts, two fragments, and there is a physical disruption. Actually, there is a physical disruption in sort of blood supply, other nutrients because of this fracture, and immediately on when it is fractured, there is an associated inflammation at around the site of the fractured bone. Okay. Now, if you take a small sample from this site, you will find a lot of things contained in that inflammatory site. It contains mesenchymal stem cells, it contains fibroblasts, it contains neutrophil granulocytes, macrophages. So it is a mixture of different kinds of cells that is contained within this inflammatory site at the fracture site. Okay, so this is designated within the first stage. What happens is inflammation. So generally we have this perception that when you see a swelling on inflammation, see when you people go to the ground, you do a lot of sporting activity, there may be sudden impact by which you may encounter fracture. Okay, and you would see, or generally that if there is a fracture, immediately there is a swelling in that site, inflammation. And this is what happens exactly. Okay. So what happened more, clearly it is visible in these slides, is that during early fracture, you see disruption in the bone structure, and there is blood clot formation in the fracture site. Okay, so you see that there is cortical bone, there is bone marrow on both sides, but in and around the fracture site, we see blood clot formation, and this is what is called hematoma, and this happens in the early stage of fracture, and this is an explanation of why this inflammation occurs. There is a huge blood clot that is formed in the fracture site. Okay, and that is called hematoma. Now I will try to narrate a little bit deeper explanation of what is happening during this early stage of bone fracture, wherein inflammation occurs. Now, bone has a very good blood supply due to its channel within its structures, due to different channels within its structures, okay, that you all know. And bone is richly supplied with blood supply. Okay, so it's richly supplied with blood, and wherever there is dearth of blood supply due to any reasons, any site, any bony site, dearth in blood supply is there. If there is dearth in blood supply, it is called a case of necrosis. Necrosis is basically where blood supply in the bone site reduces. That is called a state of necrosis. Okay, that may happen for different reasons, but generally bone has a very good blood supply due to the channels within its structure. So fracture massively disrupts this channel and causes a large amount of bleeding from the fracture segments. So this is what is explained in here. So when there is a fracture, there is a disruption and there is a blood clot formation at the fracture site. So fracture massively disrupts this channel and causes a large amount of bleeding from the fractured segments. Obviously, this causes swelling of the fractured region, and which is explained by this figure. The event that follows is hematoma formation, and of course it is basically all can be together designated as inflammation at the fracture site. So this is one figure that explains you why there is inflammation, and this is a more sort of simplified figure of the inflammation at the fracture site. So these extravascular blood cells clot and forms hematoma. Okay, this is exactly a manifestation for hematoma formation is a manifestation of disruption in blood supply due to fracture. Okay, the damaged bone tissue and the cells within the blood clot start degenerating, leading to death. Okay, so the damaged bone tissue and the cells within the blood clot, they basically degenerate, leading to cell death. Okay, so there is a fracture is basically a disruption in the whole, blood supply in a state of equilibrium, as we generally can say. The body is richly supplied with blood, the bone, and if the bone breaks, there is a disruption. And of course, if the fractured site, there is formation of hematoma. Basically, blood cells clot and forms hematoma. And those blood cells, as well as bone tissue cells, they all start to degenerate, leading to death. But near the injured area, the fibroblasts survive. So fibroblast is another cell, survive and replicate to form loose aggregate of cells. Okay? Interspread within small blood vessels known as granulation tissue. So near that fracture site, or in and around the fracture site, the fibroblasts actually, they survive. And they actually there is event of proliferation by which they can increase in numbers, and they together with the blood vessels, they form a granulation tissue. The granulation tissue forms a scaffold between the two fragmented parts, from which the formation of soft callus can begin. Okay, so as I told you, let me just go back to the event slide. First, there is inflammation, and then there is soft callus formation. So the whole event of inflammation ends with the formation of the granulation tissue in form of a scaffold between the two fragmented parts, and simply thereafter the formation of the soft callus actually begin. Okay, so formation of soft callus is initiated approximately after 4 or 5 days of fracture. It takes a bit of time to form the soft callus, or for the soft callus to start forming. So soft callus formation can actually occur between 4 days to 3 weeks. So here fibroblast cells and mesenchymal stem cells. Remember, mesenchymal stem cells, MSC, is rich. The granulation tissue is rich with mesenchymal stem cells. And these mesenchymal stem cells is primarily responsible for regeneration of bone tissue. Okay, the key towards formation of new bone tissue is mesenchymal stem cells. And the granulation tissue that is formed at the fractured site is richly supplied with mesenchymal stem cells and fibroblast cells. So this is a spongy material, the granulation tissue, as well as the soft callus. This is a spongy material that fills the gap between the two fragmented parts. Okay, so we are in the stage of the soft callus formation, and the callus remains quite weak to external stresses. However, the callus is a very, very soft callus, rich with granulation tissue, mesenchymal stem cells, fibroblasts. It is located in between the two fractured components, but it is low in strength. You can imagine that it is a very, very soft tissue. So it is weak to external stresses. However, the callus provides sufficient stability at the fractured site for new blood vessels to form or to begin forming. So new blood vessels start forming. The restoration work actually starts from all aspects with the formation of this soft callus. The next big step is transformation from soft callus to hard callus. The hard callus formation can start in between 2 weeks to 6 or 12 weeks, depending on the patient condition. Okay. So this is where complete conversion of the callus into calcified tissue occurs through ossification. Ossification is bone formation. Okay. So the hard callus is the first major steps that some amount of hard tissue in form of calcified tissue is formed through the process of ossification. Okay. The mesenchymal stem cells closest to the fracture gap develop into chondrocytes, which form hyaline cartilage. I will move into the details of the tissue differentiation from MSCs, but just to give you information, at the stage of hard callus formation, the MSCs are converted, a part is converted into chondrocytes, which are another kind of cell that finally generates cartilage. And cartilage can also be transformed into immature and mature bone. Okay, so these are all transitional stage at the hard callus formations. The MSCs, which is closest, they generally give rise to cartilage, and MSCs which are distal, further away from the fracture gap, can also develop into osteoblasts. So osteoblasts are bone-forming cells which may form woven bone. Okay, the fibroblasts within the granulation tissue can transform into chondrocyte, which can also form hyaline cartilage. So chondrocyte C, it starts with the letter C. It usually is transformed into cartilage. Okay. So after this whole process of bone, hard callus is, this event is completed, the remodeling of the bone structure starts. But remember, this remodeling is, of course, little different from what we have learned earlier. So that is implant-induced bone remodeling. That's also remodeling of the structure in form of density changes. Here it is physically there is transformation in the bone structure. Okay. So here the remodeling, loosely organized woven bone slowly transformed into highly organized laminar bone through the process of bone substitution. Okay, so the loosely woven bone that is formed at the hard callus, they slowly transform into more organized laminar bone structures. So you can see already at the fractured side, indicated by the red line, that the woven bone is transformed into more laminar structures. The hyaline cartilage is also being transformed into laminar bone through a process of ossification. We call it endochondral ossification. These are clinical terms, but ossification, some sort of bone formation procedure, which is called ossification. Through the process, actually hyaline cartilage is also transformed into laminar bone. Okay, so at the end of the fracture healing process, the bone should present its original shape, that is before fracture, and strength. So this is how a disorganized structure is organized into an original, to bring it to that original shape, and the whole process of bone fracture healing is completed, which takes about 6 to 8 weeks, depending on the patient condition. Okay, so let us stop here and ask if there is any questions at this stage. Students? Hello? Can you hear me?
Yes, sir.
Yes, sir.
Yeah. So is this whole event, the biological event, clear to you? Hello?
Yes, sir.
So if you revisit it, you would be able to learn more, because there are quite a few clinical terms. But if I have also a PDF, right? Let me open the PDF. It's available in your Google Drive, the shared folder. So that is very nicely explained with references, everything. So if you want, you can open that. I'll just open it. I'll just maybe I'll stop recording at this moment and then come back later. Where is that folder? Why can't I see that folder? Yeah. Can you see this? Bone ingrowth and tissue differentiation.
Yes.
Yeah, this is what is the PDF that is available within the Mechanics of Human Body folder. And this explains you everything. Basically, how the mesenchymal stem cells differentiate into different kinds of cells. The whole differentiation process from mesenchymal stem cells, through the process of proliferation, how bone cartilage. I'm going to explain you also in the slide very clearly. Okay, so let me move on with the slide so that this is you can read this stuff only when things are somewhat clear to you from the slide. Okay, because this is more mathematical derivations, so it's a link between biology and mechanics. So unless you understand the events properly, it is not worth to visit the mathematical formulation. Okay. So for the time being, I would ask you to concentrate on the slide itself. Okay, so I'm moving on with the slides.
Sir?
Yeah.
So how does the different bone after complete fracture understand that how much thickness they have to develop, how much density they have to develop?
See, basically our body is a very intelligent, thing, and whatever is God gifted, they try to restore to its original shape and size. Okay, so there is a inherent intelligence system you can perceive in that way. So basically, as I was telling you, that if I look into the slide, remodeling of bone, so it at the fractured site, can you see this slide? Hello?
Yes, sir.
Yeah. So you have seen that hard tissue formation. Sorry, the hard, so not hard tissue, hard callus formation, and this is a state where the soft callus is transformed into hard callus due to formation of calcified tissue, the solid part of the tissue, okay, through the process of ossification. So that is when there is bone formation back. Now, that for bone formation is still not too organized. Okay, so what happens is during the remodeling process, this whole original reconstruction is attained. Okay, it is, as you have seen, that the laminar bone formation occurs at the fracture site, exactly replicating. It tries to go back to its original shape and size, and strength. So as I had told, at the end of the fracture healing process, bone should closely represent its original shape and strength. So the whole thing is restored through the process of bone fracture healing. This is what exactly happens. So when you break your arm or if you break your leg, you end up to an orthopedician or an orthopedic doctor or orthopedic surgeon who actually tries all the trick to enable bone fracture healing, starting from soft callus formation to hard callus formation. This is basically an evolutionary process, time-dependent process. But a surgeon actually facilitates this process to happen. Okay. Now, if you say, for instance, if I go back to the fractured site, somewhat like that, or you can needs to be in place. Okay, if they move relative to each other, and it is subjected to different. This soft callus formation would be disrupted to a great extent. So the callus is relatively weak to external stresses. So that is the reason when we first fracture, when there is a fracture at the site, the surgeon tries to cover it with the plaster. See, historically we had plasters, This will hold the two bones. They first force the two fragmented parts to come close to each other, and then they put a plaster over it. Nowadays surgeons use plates and screws. Basically, they put the plates and screws. Oops. Can you see the slide? Hello?
Yes, sir.
Yeah.
Yes, sir.
Why can't I find this here? Oh, sorry. It's not going to. Yeah, I should find it now. Point. So here, what they try to do, put a plate here, down here, up there, and put a screw so that they hold the two fragmented parts very close to each other and let this callus formation happen very fast. You get my point? And once this callus formation occurs, soft callus formation, then it transforms into hard callus formation, and thereafter bone remodeling happens. After this whole process of fracture healing, you can basically remove these plates and screws because the bones are now healed up. The fragmented parts of the bone are now healed up to its original shape and strength, and therefore there is no need, there is no function of the plates and screws anymore required for load transmission. The plates and screws, the purpose of the main function of the plate is to facilitate fracture healing. No other reason. Do you get my point?
Yes, sir.
So let us move forward. So treatments of bone fracture can be surgical. So as I was telling you, use of metal rods, plates to hold the bone pieces together. And there is a conservative approach also, use of pain relieving medicine, use of braces, plaster cast to provide support and immobilization of the bones. So of course, if you have any sort of experience with handling fracture, the doctor will advise you complete rest so that there is no movement between the two, no relative movement between the fractured parts. Okay, so that is very required, very basic requirement for fracture healing, and that can be facilitated by use of plaster as well. But nowadays, I don't think they use plasters anyway. Plasters are a problem because they cannot breathe through the plaster, and the whole tissue and skin becomes very dry after you open the plaster after, say, 4 to 6 weeks. And it takes, it takes quite a while to actually bring it back to your original, because there is no air transmission there. You don't, the tissues don't receive any sunlight. So obviously the soft tissues, the skin, the other soft tissues also degrades with plasters. So nowadays the doctors are not willing to use the plaster cast too often, unless he's forced to. Now, important note here, immobilization of the joints or the fragmented parts is a primary requirement to fracture healing. Why? Why is the question? Movement of fractured fragments prevents osteoblastic activity and formation of new bone. Okay, so if the fractured parts are moving relative to each other, there would be hardly any osteoblastic activity. You know what is osteoblastic activity? Bones, it's bone cells. It is a type of bone cell, and it facilitates bone formation. Okay, osteoclast and osteoblast are two types of bone cells. One is bone responsible for bone formation, another is called bone cell degradation. Okay, so you have two. Osteoblastic activity is the favorable activity which is responsible for new bone formation. So the essence of the story is the mechanical environment. Again, the mechanical environment around the fracture site is somewhat, to a great extent, to a great extent, regulates the fracture healing process. So this triggers the mechanobiology, a whole big area of mechanobiology of bone fracture healing. I have about 8 minutes. Now, this is a very important slide. I will request all the students to be very attentive here. Okay. So I'm summarizing the biological events. And you can see that the mesenchymal stem cells, MSCs, and the granulation tissue that is formed at the fracture site is rich with mesenchymal stem cells. These mesenchymal cells can actually form fibroblast, chondrocyte, and osteoblast. Okay? And from each, it can differentiate, fibroblast can differentiate into fibrous tissue. Chondrocyte can differentiate into cartilage. Osteoblast can differentiate into bone, they form. But from fibroblast, you can get actually chondrocyte and osteoblast. From chondrocyte, you can get osteoblast. Okay. So apart from directly from fibroblast, it can form fibrous tissue, but a part can also be differentiated into chondrocyte and osteoblast. Chondrocyte can differentiate into osteoblast as well as cartilage, and but osteoblast can only differentiate into bone. Okay. Now, what are the different kinds of biological events? It starts with cell migration. So there is a transport of cells, position. Okay. So you can see the cells are migrating from one place to the other. Cell proliferation means this formation or cell division into same type of cells. Okay, so stem cells into stem cells. Okay, so it is formation of same types of cells, not different types of cells. Differentiation is basically, actually, it is formation of different kinds of cells. So fibroblasts differentiating into chondrocyte and osteoblast is an example of cell differentiation. Okay, they are forming different kinds of cells, but from one fibroblast cells, there can be 10 more fibroblast cells. That is cell proliferation. Okay. Thereafter, this differentiation, there is tissue formation. Tissue formation means this bone, cartilage, or fibrous tissue, and that is through a process of formation or generation of extracellular matrix. Now, I would not go today into the mathematical modeling because this is something we don't have too much time. Maybe just this slide. That there have been various mathematical models proposed by researchers all over the world, but one of the very eminent papers is by Lacroix and Pendergast. They worked in Trinity College Dublin. I know them individually, and they have been working for a long time on this tissue differentiation process, the mathematical models. So they have come up with a very smart procedure, a very shortcut procedure, but very effective in this mathematical modeling procedure of tissue differentiation process. They use the diffusion principle. I hope everybody knows what is the diffusion principle. Okay, so you have, I think, studied in fluid mechanics. But this diffusion principle doesn't explicitly model cell proliferation and migration, but they are all combined together to form the one diffusion principle. So cell proliferation and migration are modeled by diffusion process, and cell differentiation means what type of new cells will be formed is basically decided by an algorithm. It's decided on certain recommendations, certain criteria that we will discuss in the next class. Okay, so I would like to end the class here and ask you people to stop presenting. So can you hear me? I'm back in the class. Yeah. So I try to summarize what is this bone fracture healing, mostly biological events. Okay. If you go through it, I will continue this discussion tomorrow. So let me finish the discussion, the slide. By Friday, I will finish everything. Okay. And there is, in the next class, as I was telling, I've just entered the mathematical modeling, but I will elaborately discuss on the mathematical modeling. The diffusion process, which is the phenomenological model, as you have seen probably in the slide, phenomenological modeling. There is a detailed cell phenotype modeling as well, where each and every type of cells, the process, its contribution can be modeled using the differential equation. I will discuss that in the class, next class, right? So please be attentive, because this may be a little difficult for you to follow, because there is a rich amount of biology involved in this whole. So initial part, you have to get over it. I have summarized it in a very easy manner so that it's easy to understand. But remember that slide where I summarized from mesenchymal stem cells to fibroblast, chondrocyte, and osteoblast, and how they are getting transformed into different types of tissues. That is very important. Fibrous tissue, cartilage, and bone. Okay. I think it's time to stop the class. 10:59. Okay. So tomorrow we will be meeting anyway at 9 o'clock. If you have any questions, you can ask me tomorrow or day after tomorrow, anytime. I'm more than happy to answer it. Okay, thank you. Thank you, everybody.
Thank you, sir.